Panspermia, meaning all, and sigma pi epsilon rho mu alpha, meaning seed, is the hypothesis that life exists throughout the universe, distributed by meteoroids, asteroids, comets, planetoids, and also by spacecraft in the form of unintended contamination by microorganisms. Panspermia is a hypothesis proposing that microscopic life forms that can survive the effects of space, such as extremophiles, become trapped in debris that is ejected into space after collisions between planets and small solar system bodies that harbor life. Some organisms may travel dormant for an extended amount of time before colliding randomly with other planets or intermingling with protoplanetary disks. If met with ideal conditions on a new planet's surfaces, the organisms become active and the process of evolution begins. Panspermia is not meant to address how life began, just the method that may cause its distribution in the universe. Pseudo-panspermia argues that the prebiotic organic building blocks of life originated in space and were incorporated in the solar nebula, from which the planets condensed and were further, and continuously, distributed to planetary surfaces where life then emerged. From the early 1970s it was becoming evident that interstellar dust consisted of a large component of organic molecules. Interstellar molecules are formed by chemical reactions within very sparse interstellar or circumstellar clouds of dust and gas. The dust plays a critical role of shielding the molecules from the ionizing effect of ultraviolet radiation emitted by stars. Several simulations in laboratories and in low Earth orbit suggest that ejection, entry and impact is survivable for some simple organisms. In 2015, remains of biotic life were found in 4.1 billion-year-old rocks in Western Australia, when the young Earth was about 400 million years old. According to one of the researchers, if life arose relatively quickly on Earth, then it could be common in the universe. History. The first known mention of the term was in the writings of the 5th century BC Greek philosopher Anaxagoras. Panspermia began to assume a more scientific form through the proposals of Jöns Jacob Berzelius, Hermann E. Richter, Kelvin, Hermann von Helmholtz, and finally reaching the level of a detailed hypothesis through the efforts of the Swedish chemists Svante Arrhenius, Sir Fred Hoyle and Chandra Wickramasinghe were influential proponents of panspermia. In 1974 they proposed the hypothesis that some dust in interstellar space was largely organic, which Wickramasinghe later proved to be correct. Hoyle and Wickramasinghe further contended that life forms continue to enter the Earth's atmosphere, and may be responsible for epidemic outbreaks, new diseases, and the genetic novelty necessary for macroevolution. In an Origins Symposium presentation on April 7, 2009, physicist Stephen Hawking stated his opinion about what humans may find when venturing into space, such as the possibility of alien life through the theory of panspermia.